All right, solutions here to review assignment number 14. So on a separate piece of paper, you can write down your review assignment number 14. All right, what are we doing? So we have a graph, and you're asked to find area, and volume. All of those are what type of questions in calculus? Think. Is that a limit? Is that a derivative? Or is that an integration question? Good. So it is an integration question. And we know we're going to go top, subtract bottom. For R, let's look at it. So R is right here. How do I go top, subtract bottom? Well, I need to know this point. We're going to do that in a moment. And then I'm going to split it into two integrations. One on the left and one on the right. But I need to know what that point is. So I'm going to take out my calculator. You should do too. I want you to find that point of intersection using these two in your graph. Can you do that for me? And then press play. All right, now that you've tried it, I'm going to trust you that you tried it first. I have something fun here. I'm going to delete that. I have it in parametric mode, so I'm going to change it. Sometimes when the mode is wrong in terms of, like, you see the term like relation, this was in parametric, press menu and go to graph number 3 and then press 1, so it's a function again. So there it is. So the first function is just tangent x. And then the second function, press tab again. I'll change the window in a second. Press tab again, and it's 2 minus x cubed. So let's just put it in to begin with. Then I'm going to change the window so I can see it. So I'm just going to change it from 0 to 2. So menu, window, settings, and I'm just going to go from 0 to 2. I think that's fine. Well, let's make here so you can see a little better. Let's do the window again. Let's change the second one. So 0 to 2 is good. Here, let's try, maybe this is like negative 10 and positive 10 or so. That didn't change it much. Anyways, you can see in terms of, I need to find where this point of intersection is. So it doesn't really matter. So menu, analyze, and then point of intersection, that's 4. So I'm going to move it to the left. There it is. I'm going to move it to the left. It's already to the left. There we go. Press down and then highlight over it. And then what is that point? And it's 0.902. So I need to know that point. 0.902. So I'm going to integrate from 0 to 0.902. Right? Good. And then top, subtract bottom. So this is the first area there. So from 0 to there, what's on top is tangent, and then what's on the bottom is 0. So it's tangent x subtract 0, or just that. And then the second integration goes from 0.902. And then I need to know this right here in terms of from here to here. So I know that, but I don't know this one yet. So let's use our calculator. That's the 0. So let's see if I can use the graph and find the 0 there. So I'm going to move this one out of the way. Then I'm going to go menu, analyze, 0, and then again I'm going to see where that is. So I had to pick which one I wanted, which was the second one, and then highlight over it, and I get 1.259, 1.260. So I'm going to do that, 1.260. And that's the second function, which is 2 minus x cubed. And then I'm going to type all of that in the calculator for the answer. So we're going to go menu, calculus, integrate. I know it's a little blurry. We're going to go 0 to 0.902, tangent. Then I'm going to move the cursor and add. I'm going to do it again. Menu, calculus, integrate. Now it's going to go from 0.902 to 1.260. And this one's going to be 2 subtract x cubed. And then go, oops, try again. Oh, what happened? Did it all go away? All right, let's try it again. So menu, calculus, integrate from 0 to 0.941 by 902, and tangent plus, again, menu, calculus, integrate from 0.902 to 1.260, and that's 2 subtract x cubed. There we go, I finally moved it across. And then the answer. So that area is 0.729. Okay, part B says find the area of S. So for the area of S, we're going to integrate from 0 to 0.902. We only need one integration for S because the whole time the top and bottom are the same. For this one, top and bottom, it changed. Here, it's the same. So it's going to be 2 minus, it's this one's on top, subtract this one, from 0 to that number. So 2 subtract x cubed, subtract tangent x, and then put that in the calculator. So menu, calculus, integrate 0 to 0.902, and then it's going to be, what is it? 2 subtract x cubed, subtract tangent. And you get 1.160 or 1. And then part C, find the volume of the solid generated when S is revolved. So if I take S and revolve it around the x-axis, there's a space here between this area and the x-axis. So I need 2 circles. So let's set it up first. That's part of the issue. So we're going to set it up. For S, it goes from 0 to 0.902, and we need 2 circles, a big radius and a small radius that we're going to subtract. So the big radius goes from the top all the way down to what you're revolving around. So right here, from the top all the way to what I'm revolving around. So that is 2 minus x cubed, subtract 0, or just 2 minus x cubed. And then the small radius goes from the bottom of that to what I'm revolving around. So that's tangent, subtract 0. Or just tangent. And then we type that in the calculator. We do that. So again, 0 to 0.902. Oops, what did I forget in front? Pi. Important, right? So there's the pi that I forgot. Here, we're going to go 2 subtract x cubed. And I'm going to square it, subtract, parentheses, tangent. I'm going to square it, and then dx. And this will give me the volume. 8.331 or 2. And you did it. So there's question number 1 done. Honestly, a fairly basic question in terms of setup. Like, I understand it's integration, find the bounds, top, subtract, bottom. Maybe part A was the tricky one where you had 2 integrations. But part B and C, Those are more basic area and volume questions that we need to get better at. All right, number 2. The temperature in Celsius is given by a table. And so you have the number of days and what the temperature is in the pond, water in a pond, as recorded every 3 days. Use the data from the table to approximate the derivative at 12. So the derivative of 12, we're going to use the 2 points in front and behind it. And we're just going to use the slope formula. So that's going to be 21 take away 24 and 15 take away 9. We don't have to reduce it down. And then it says make sure you know your units. So this is, the units are temperature, like degrees Celsius per day. If I do reduce it, it's what, -3 over 6 or -1/2. So over that, and then it says, I'll show the computation, we did that, and we have the unit in terms of degrees per day. All right, approximate the average temperature in degrees of the water over the interval from 0 to 15 by using a trapezoid. So average value, we're going to integrate from 0 to 15. We're going to integrate what we see, and then divide by the difference of the bounds. So to use a trapezoidal, first of all, the width is top subtract bottom divided by how many trapezoids we have. 3 days. All right, so the average width then is 5. So 1/2 times 5, right? No, 3, right? We're just going to do 3. It's going to be 5 trapezoids. It's 3. That's the width. When they give you it, that's the 3. Then the first trapezoid, and then double the next one, 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 and then the last one single, right? And that's divided by 15. And that's it. You wouldn't even have to simplify it. So there's the trapezoidal rule, divided by 15. A student proposes the function be given by that as a model for the temperature of the water in pond T, where T is measured in days and in Celsius. And it says now find the derivative at 12 using that. So just use your calculator and find the derivative at 12. So we're going to go menu derivative at a point. So menu calculus derivative at a point. We're going to use t, and the value is at 12. And then we're just going to type in 20 plus 10t times e to the negative t divided by 3. That's it. And you get negative 0.549. And that is in degrees per day. So what does it mean? The rate of change of the temperature of the pond water is negative, almost -1/2, like, right, degrees Celsius per day on the 12th day. So the temperature is getting colder, right? By that. That's the rate that's happening. Part D. use the function defined in part C, that's this one up here, to find the average value over that time. So again, we're going to integrate from 0 to 15. We don't have to write it out. It's already p at t, and then divide that answer by 15. So that's the average value formula. We're going to type that into our calculator. So control divide for a fraction line, and then I'm going to calculus integrate, goes from 0 to 15, and then I'm going to type that in again, 20 plus 10t times e to the negative t divided by 3 divided by 15. I type it in right, I think so. So it's 26 or so, 25.757. So that's the average temperature in terms of you take all the data in terms of those 15 days. All right, number 3. A car is traveling on a straight road with a velocity of 55 feet per second at t0. So they give you an initial value where the velocity, the initial velocity is 55. From 0 to 18 seconds, the car's acceleration is that piecewise that you see. So what I see is the acceleration. And then the question is the velocity of the car increasing at 2 seconds? So velocity increasing means acceleration, and it's seeing if the acceleration is positive. So at 2 seconds, the acceleration is positive, which means yes, it's increasing. So in part A, the answer is yes, velocity is increasing at t equals 2 because the acceleration at 2 is positive or greater than 0. Part B, at what time from 0 to 18 is the velocity 55 feet per second? So to know when that happens, the initial velocity is 55, and then we're going to integrate from 0 to something of that acceleration, and that answer has to be 55. So what we're really finding is this. So obviously the beginning velocity is that. So when does it go back to 55? So we increased here. Where is it where this area matches this area down below? So it's like 1, 2 across. So from here, 1, 2, right here, right? This area now matches this area. So it increased, but now it decreased to the same number. So at 12, it's going back to 55. So we started at 55, and then as I go from 0 to 6, it's increasing. And then after 6, it decreases, and then eventually gets back to 55 when these two areas match. So when t equals 12, it equals, the velocity equals 55 feet per second. And then it continues to decrease. And then when it increases, this area is not big enough. So it continues to go down, and this area is not big enough to get back up to 55. There's only one spot where it's also 55. C, on what time interval from 0 to 18 is the car's absolute maximum velocity, and what time does it occur? So when you integrate, you see what it is. So here we have increased, and then here we decrease. It's going to happen right here. So at 55, we increased all the way to 6. And then look at all the decrease. So we decrease and continue to decrease below 55. And then we increase, but we don't even get to 55. So right there at 6, we have increased from 55 the most. And at 6 is the absolute maximum. And if you think of the integration, that integration from 0 to 6 is that max value. At what time from 0 to 18, if any, is the car's velocity equal to 0? And then justify your answer. So, we have to figure out these areas here to think, is this exactly the same? All right. So, this area, let's figure out what this area is. The first trapezoid is 1/2, the height is 15, and the two bases are 2 and 6, that's 8. So half of 8, 4 times that, that's 60. And so this goes from 55, we add 60, then subtract 60, so now we're back to 55, right? We added 50, 60, we subtracted the same area. Now what's the area of this trapezoid? The one on the right. So the height again is negative 15. You do it right here. That's 1/2 that. And then the two bases are 2 and 4. So they add up to 6. So that is 3 times negative 15. That's negative 45. And then we have a triangle that we add. So the answer is no, because 55 take away 45, we are already at 10, and then we're going to add the triangle after that, which is half the base times the height. And at no time does this equal 0. So we started at 55, we added 60, subtracted 60, subtracted 45, and then we added the triangle at the end. So the answer is no, there's no point. So that means it never rested. And you're done. All right, turn the page. Number 4. So let h be this function defined, except for x equals 0, so that h at 4 equals negative 3. So h at 4 equals negative 3, and the derivative is x squared subtract 2 over x. And it says find all the values of x for which the graph has a horizontal tangent. So you make it equal to 0 and solve. So just the numerator, and if I solve it I get positive and negative root 2, and those are your horizontal tangents. Turning points. So take the derivative, horizontal tangent, take the derivative equal to 0, we just need the numerator, and then we solved it, and we have the two numbers. And then it says, determine whether it's a max or min. So draw a number line for the derivative, and then plug in. So if I plug in like negative 10, it's a positive over a negative. Plug in, I can't plug in 0, so plug in 1. It's a negative over, try again. Yeah, if I plug in negative 1, it's a negative divided by a negative. And if I plug in 3, right? What did I do wrong? Let's try that again. So this is like x plus root 2, x minus root 2 over x. I think I did the first one wrong. So negative times a negative divided by negative. That's a negative. Then the next one, so at negative 1 is a negative. No, it's a positive, a negative, and a negative. So it is positive. And then if I plug in like 5, it's a positive, positive, positive. So it's positive. Doesn't feel right. What did I do wrong? Oh, you know what I did wrong? I still need to include, good lesson to learn here, I still need to include 0 as a, that's what I'm doing wrong. where it's undefined, I still need to include it on the number line. It wasn't coming out the way my brain was going to come out. So I knew this. Let's try again. This is negative, positive, negative, positive. Now I feel better about what's happening. So at negative root 2, it's a minimum, and at positive root 2, it's a maximum. So if you pick negative 1, it's a negative times a negative 1 is a positive, negative, negative. It's a positive. If I pick a positive 1, it's a positive times a negative, which is negative, divided by a positive, and that's where this happens. Anyways, we have a minimum at negative root 2. And we have a max at positive root 2. Got through that. And the work you show is justifying your answer. Part B. On what intervals is the graph concave up? Well, I need to take the derivative. That's going to be the quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom and then the bottom squared. I need to make it equal to 0, so only the numerator here. That's 2x squared minus x squared plus 2. So 2x squared minus x squared negative negative plus 2. Combine like terms. And it's never. So we end up with x squared plus 2 over x squared. All right, so there is no answer here for that. So that means entirely, it's always positive. No matter what number you put in, the answer will always be positive. There's no answer for a point of inflection. So where is it concave up? And the answer is everywhere. Write an equation for the line tangent at x equals 4. So at x equals 4, from the question, so 4, negative 3, and then the slope, you plug in 4 for x. So 4 squared, take away 2, and then 4. So I get 14, that's fine. That's 14 over 4, x minus 4, subtract 3, using the values for x and y. That's great. And then part D, does the line tangent of the graph lie above or below the graph for h for greater? So if something is concave up, so at 4, it is increasing and concave up. So if something's increasing and concave up and you have a tangent line on that, this tangent line is below. And so why is it below? Because it's increasing and concave up. So if I draw a picture of increasing and concave up and draw a tangent line, you can see it's below. If it was the other way, you could see that it's the other way if it was concave down, let's say, or so on. All right, last one. What do we got? We got number 5. 2 more. So we have 4x cubed plus ax squared plus bx plus k. A, b, and k are constants. The function has a minimum at x equals negative 1 and has a point of inflection at x equals negative 2. And then it says find the values of a and b. So we're going to take the derivative. That's 12x squared. That's 2ax. That's just b. And then when you make it equal to 0, x is negative 1. So when it's a minimum, you take the derivative equal to 0 and plug negative 1 in for x. And what would make this 0? So I have 12. I have negative 2a plus b. So I'm going to rearrange this as 2a minus b equals 12. Then I'm going to do the second derivative. So I just added 2a, subtract b equals 12. The second derivative is 24x plus 2a. So I'm going to make it, a point of inflection means it's equal to 0. I'm going to plug in negative 2 for x. So I get negative 48 and 2a. I'm going to solve it. I'm going to add 48 and divide by 2. So I already know a is 24 I'm going to plug that in here for A, and then I'm going to solve for B. So I have 48 minus 12. So that means B is, what, 36? So I have A is 24, and I have B being 36 for that to work. And then it says, if the integration of all that is 32, what's the value of K? So I now know what A is. So I have 4x cubed plus A, 24x squared, B, 36 plus K. So I plug that in. If I integrate this, I add 1 to the, and then divide. I add 1 and divide. So 24 divided by 3. I add 1 and divide. Half of 36, what is that? 18. And then just be kx plus. Now, we don't need to go plus c because we know the area. So the answer is 32. And then I need to solve for k. So then, if you integrate from 0 to 1, the answer is 32. So I'm going to plug 1 in. And then subtract. If I plug in 0, the answer is 0, and then that's equal to 32, and I'm going to solve for k. So 1 plus 8 plus 18 plus k. And so if I subtract all of this, I actually don't need to simplify it. And there's my answer. All right, number 6, last one. We got this. We have a point 3 1/4 on the graph f at x. The slope of each point, the derivative, is that. Well, it feels like a diffie q. Let's see if that's true. And it says, first of all, take the derivative of that. So we can do that. So the second derivative this is going to be the product rule. So the first times the derivative of the second plus the second times the derivative of the first, but we need a y prime. And instead of y prime, I can just put in what y prime. This is equal to y prime. So then I can just put in y squared 6 minus 2x for it. So it would have been 2y times y prime, but this is what y prime equals, so plug that in for y prime. And then you evaluate it at that point. Again, we don't have to reduce it down, which is good news. So we're going to plug in 3 1/4. So where there's a y, we plug in 1/4. Where there's an x, we plug in 3. Just be patient as we go across. And then be done. I don't need to solve that. That's good. So that's the second derivative at 3 1/4. So at 3 1/4, you plug it in. You don't have to simplify it. And then part B, here's your last part. You're going to solve the diffie q, right? So to solve this diffie q, we're going to separate the variables. So we're going to divide by y squared, and we're going to multiply by dx. And then we're going to integrate this. So we're going to write it calculus friendly. Don't think it's an exponential. It's not. We're going to write this calculus friendly, and then to integrate means we're going to add 1 to the exponent and divide. This is 6x, and this is x squared. You add 1 and divide plus c. Multiply by -1. Well, we can plug in the point right now. So the point is 3 1/4. So 1/4 and then 3, right? And then solve for c. This just means the reciprocal. That's 4. And it's negative because we're dividing by -1. This is 9. So -4 subtract 9, and you get your answer. So we have y to the -1. We're going to rearrange this in a second. Is equal to -13. To get y by itself, we're going to multiply everything by -1. order doesn't matter. And then this means reciprocal. Remember, y to the negative 1 means 1 over y. So to get y by itself, we just go 1 over, and we have our answer. Done. And you just solved the Diffie Q. All right, Mr. G Math over and out. Great job doing your review today. Till next time.